Good evening, everyone. This is chemistry, Chem 2 week 3. Let's get started. Which of the following mixtures are best separated into its components using simple distillation? You guys should have all of this really well known by now. We took it in grade 9. We had a few AMSs on it, so I believe you should know all of these. So simple distillation, I'm not going to really go through it that much. It's in the notes if you want to go back to it. Everything is here. I think it's so simple distillation here. Yep. So, and the same questions in the course version. So please know these well if you don't know them. But simple distillation is for sodium chloride aqueous solution and the sugar alcohol solution. Question 2. A mixture of miscible liquids having close boiling points. Immediately as you see close boiling points, it's fractional distillation. Question number 3. A mixture of amino acids is a colorless solution. However, the mixture can be separated and analyzed using chromatography. Which of the following techniques can be used to identify the amino acid spots when separated by chromatography? So first, exposing the paper chromatograph to UV radiations to reveal the spots. That's the first way. The second method is spraying the spots with a locating agent that reacts differently with the components of the mixture. Again, this is all in the notes. Please, I would advise to look over the notes. It would really help. It would really help. Question number 4. What volume of 3.00 molar of H2SO4 contains 0.150 moles of acid? So basically here, we're trying to find the volume. This is our target. I have the molar mass, which is C, and I have the number of moles. Looking at these three values, I know the relation is N equal CV. I'm trying to find V. I need to divide both sides by C. So therefore, N over C is nothing but V. So the number of moles, which is 0.150 divided by 3.00 gives you the volume, which let's put it on the calculator real quickly. Okay, so 0.15 divided by 3, you get 0.05 decimeter cubed. So 0.0 should be 500 decimeter cubed. As you can see, they wanted in milliliter, and I know that 1 decimeter cubed is 1,000 liters. So therefore, I'll have to multiply by 1,000. As you can see, I went from 1 to 1,000. So I'm going to multiply my answer by 1,000. I get 50.0 milliliter to 3 significant figures, as you can see. Pretty straightforward question. We use first, I look at my given. I need to find the volume. I have C, I have N. Using a relation N equals CV, N over C is V. Dividing 0.150 over 3.00, you get 0.0500 decimeter cubed, which is 50.0 milliliters. Moving on. Select the apparatus required to perform filtration. So this is a beaker. Of course, we don't need an evaporating dish. For filtration, we don't need a Bunsen burner, and forgot the name of this, to be honest. But we need the filter funnel, as you can see here. If I'm not mistaken, it should be somewhere here. Yep. So we need the residue lies on the filter paper. That's the filter funnel. A conical flask or a beaker, you can use any, and the filtrate, which is the water. Usually it's water. Moving on. Examples of elements include hydrogen and sodium. I would think that most of you guys know this, so I'm just gonna move on. Example of compounds include calcium carbonate and water. I would believe also that most of you guys know this one. Moving on. Example of mixture includes steel and paper. Steel is a mixture of metal, and paper is just a mixture of many things. after a gas is dried, it should not be collected over water. Why this is the case? Because after drying, a gas should not be collected over water because water can dissolve, react with, or contaminate the gas, affecting its purity and volume. Therefore, it affects the accuracy of the collection process. So therefore, that's why we do not collect the gas immediately after it's dried over water. Moving on. Okay, very important question. I'm gonna take it on the open board. Okay, so they're telling hydrogen gas H2 reacts with carbon monoxide gas to produce methanol CH3OH as shown in the following reaction. 2H2 plus CO gives CH3OH. When 0.50 tons of H2 reacts completely with CO gas, the amount of methanol produced was 3 tons. So when I tell you 3 tons, this is the actual yield. So I'm gonna call this the AY, the actual yield. Calculate the theoretical yield of methanol. So the theoretical yield is basically the yield we use. Like it's one. There are like no experimental errors or like no anything lost to the surroundings. It's the one that we. It would be if the theoretical yield is equal to the actual yield, then the percentage yield would be 100%. Most of the time it's not. Ideally it's not. Nothing is ideal basically. So to calculate the theoretical yield, this is how to do it step by step. There are 3 steps to do it. Okay, the first step, and this is very easy. It's just let's go over it slowly. So H2. Let's just write the molar mass of H2. H2's molar mass is 2 grams per mole. Right? You guys should know this. And then carbon monoxide's molar mass is 28 grams per mole. And CH3OH. This is 28 gram per mole. Actually, I modified شوية. So 28 gram per mole. CH3OH, sorry, is 32 gram per mole. If somebody doesn't know how to calculate the molar mass, just tell me in the comments. So that's step 1 done. Easy. I just identified all the molar masses. Now for step 2, I'm gonna continue my work here. For step 2, I know that 1 ton, you should know, and the 1 ton is 10 to the 6 gram. So if I have 0.5 ton, as they gave me in the given, 0.5 ton of H2, that is 500,000 gram. To find the moles of H2, I need to do the mass of H2 divided by the molar mass of H2. So therefore, it is, sorry for the very bad handwriting, my mouse is not really accurate. So 500,000 divided by 2, you get 250,000 moles. Okay, 250,000 moles of H2. To find the moles of H2, we found the moles of H2. To find the moles of CH3OH, again, I'm saying COH for some reason every time. Excuse me on that one. So CH3OH. Looking at the given, here its ratio, it's 1 to 2. So basically, it's the number of moles of H2 over 2 from the given, from the equation. So it's 250,000 over 2. You get 125,000 moles of CH3OH. Okay, that's step 2 done. for step 3, I'm gonna continue this down here a little bit. For step 3, to find finally the mass theoretical yield of CH3OH, I'm gonna use the formula in the mass of CH3OH equals the molar mass of CH3OH times the number of moles of CH3OH. So this is the molar mass of CH3OH. We said from the beginning it's 32. So it's 32 times 125,000 you get 400 a day. You get 4 million. Well, let me check. Let's check. So it's 32. So 32 times 125,000. You get 4 million, and then if I divide by 10 to the power 6, you get 4 tons. So you get from this one 4 million. 4 million gram. They want it in tons, which is 4 ton, because as we said, if I go back, 1 ton is 10 to the power of 6. So to go from gram to ton, I divide by 10 to the power of 6. So that's what I did. So divide by 10 to the power of 6 is 4 tons. So that is the theoretical yield. To calculate the percentage yield of the reaction, the amount of methanol produced, which is CH3OH, is 3 tons. The theoretical yield is 4 tons. The formula for it is actual yield over theoretical yield times 100 gives you the percentage yield. Okay, so the actual yield is 3 over 4 times 100 is the percentage yield, which is 75%, and I will show you now on the calculator. So 3 over 4 times 100 is 75, and don't forget your percent. Next, a student wanted to find the maximum mass of aluminum oxide Al2O3 produced when a sample of 0.800 moles of aluminum Al reacts with excess oxygen gas O2. The chemical reaction, the chemical equation of the reaction takes place is represented below. Calculate the maximum mass of Al2O3. So basically, here all we have to do is they gave you the number of moles of aluminum. Let's work on it. So how I like to solve, I just write aluminum and I write, let's say, Al2O3. Okay, aluminum was originally 4 moles. This Al2O3 was 2 moles. Aluminum became 0.800 moles. So this becomes X moles. Okay, so basically to find X, I need to do 2 times 0.8 over 4. So now the new number of moles of it is 0.400 moles. Okay, to calculate the mass, I multiply the moles. So let me just go step by step a little bit. We don't need to speed it up. So X equals to 0.400 moles of Al2O3. Then, excuse me, to find the mass, as we said, is the molar mass times the moles. The molar mass of Al2O3, they told you here, it's Al2O3. So you multiply Al2, so it's 2Al, so it's 27 by 2, plus 3 oxygen, so 3 by 16, you get 102. So it's 102 by the number of moles we got, which is 0.400. Let's hope we get the answer right. Bismillah. And we do. So The maximum mass is 40.8 grams. Moving on. Okay, this question has been repeated for many weeks now, but let's go over it again. A student wants to obtain potassium nitrate crystals from its aqueous solution. So that means that he has to perform crystallization. This question will come, I believe, almost copy-paste, but they will change the wording a little bit. So please focus on this. Step 1 in crystallization, you heat the solution on a Bunsen burner or over a Bunsen burner until most of the solvent, which is the water, evaporates. Then, you transfer the mixture to an evaporating dish in a water bath. After that, you heat it carefully until the remaining solvent evaporates completely. At the end, you leave the obtained crystals to dry overnight. I believe you guys know this as well. Okay, again, this question comes a lot, as we have seen it for quite a while now. And all of this is in the notes. It's really all of this, it's in the notes. Please go over the notes. It helps a lot. There it is. Okay, they're telling you the following. Choose the component of the dye that is least soluble in solvent action and has the most affinity to the paper. Okay, when they say most affinity, that means it's the least soluble component. And the least soluble component that has the most affinity to the paper is the one that is closest to the baseline, which is C. In the exam, it's A. Because in the exam they ask for the least affinity. Least affinity, yani it travels the most distance from the baseline. To find the RF value of component A, you do the distance of the component A from the baseline divided by the distance from the baseline to the solvent front. So basically, you divide 10 over 12, you get 0.83 repeating. In the exam, it's 0.67. Select the burette that contains 25.2 centimeter cubed. Okay, people might tell me, no, okay, these two we can cancel them out immediately, but why is this مثلا the answer, but not this? Basically now, as you can see here, the gap between مثلا 24 will 25, it's it's small margins, very small margins. Then let's see here. This 25.2, 25.4, 25.6, 8, 26. If I look here, look, it's a smaller margin. So this cannot be 25.2. It cannot be 25.2. So therefore, it's the first one. Moving on. Here, and you just have to look at it. It's above 25 by 2 units, so it's 27.0. Please write 27.0. Please 27.0 or 27. Since 27 is accepted as well, but I would prefer 27.0. Okay, here it's pretty. You guys should know this really. This is very simple, and this is all in the notes. So please go over the notes as I said. Okay, so it's 16 minutes. And it's 31, 2, 3, 4, 5, 6, 7, 8.5 seconds. Moving on. Select the syringe that contains around 40 centimeter cubed of gas. Okay, guys, sublimation is used to separate a mixture of iodine and salt. You guys should know this. It's in the notes. So please go over the notes. Decantation using a separatory funnel is used to separate liquids that form two distinct layers. So, guys, this is all memorizing. So please memorize all of this stuff. What volume of hydrogen is produced at STP when 6.50 grams of zinc reacts with excess HCl solution? Okay, the formula here that we want to find the final volume. Okay, now to find the final volume of hydrogen produced at STP of 6.5 grams. Okay, so the formula says that N times the volume at STP gives you the actual volume of the substance. So basically, I need to find the number of moles. Because I have a problem. They didn't give me the number of moles, but I can find it. So 6.50 grams, we know the number of moles is mass over molar mass. So 6.50 grams of zinc over molar mass of zinc is 65 times the volume at STP, which is 22.4 liter per mole, is your volume. Calculator. So 6.5 65 by 22.4, you get 2.24 decimeter cubed. Okay, these formulas from grade 9, guys. Please, from grade 9, you guys should know them. You guys should know them by now. Okay, here. A hydrogen carbon containing only carbon and hydrogen is 30% hydrogen by its weight. How many grams of carbon and hydrogen do 100 grams of oxygen of the compound contain? Give you all your answers to 3 significant figures. Okay, guys, this is شوية common sense, but I'm gonna explain it to you on how to solve it if in the exam they change the numbers, for example. Okay, to solve this, مثلا we're gonna start with the hydrogen because that's what they gave us, right? So mass of hydrogen is the percentage of hydrogen over 100 times the total mass of the compound. So basically, this is a percentage of hydrogen, which is 30 out of 100, multiplied by the total mass, which is 100. So basically, this cancels with this. So the total mass of hydrogen is 30 grams. And you can do it 2 ways على طول إنه okay, I'm just gonna scroll this up. So the mass now of the carbon is, you need to subtract the 2 percentages. So the percentage of carbon is 70%, right? Because of this 30%, 70% remains for carbon. So basically 70 over 100 times 100 cancels. So it's 70 grams of carbon and 70 grams of hydrogen. Okay, so this is how to do it. Let's say if it was not really common sense numbers as it is here, because it's 30% of 100, it's 30% immediately hydrogen. Okay, this question is very, very important to know how to do it. 100 grams of hydrocarbon containing only carbon and hydrogen contain 20 gram hydrogen and 80 gram carbon. What is the mole ratio of hydrogen atoms to carbon atoms? Please follow the steps I will do right now. Okay, so we're going to take this to open board and let's solve it carefully. Okay, first I'm going to do the number of moles. I'm going to check the number of moles of both of them. So basically, we know the number of moles again is the mass على molar mass. So let's find the number of moles of H2. Number of moles of H2 is 20 grams over 1 mole, because you know I want to find the over 1 molar mass, my bad, over 1 gram per mole. I don't know why I said mole. That's gram per mole. So it's basically gram by gram, so it's 20 mole. Well, number of moles of carbon is mass, which is 80 over molar mass of carbon given 12. So gram per mole. You get إنه gram بيروح. This is approximately approximated to 6.67 moles. Always in this case, when you have to ratio the mole, you take the one with the less. You take the lower mole, and then you divide it on both sides. So basically now, I'm going to divide the 6.67 by 20. So H2 will be 20 over 6.67. Well, carbon will be 6.67 over 6.67. basically this is gonna be approximately يعني 3, this is gonna be 1. So the ratio of hydrogen to carbon is 3 to 1. I hope you guys understood this video. If you have any questions, feel free to comment, and I hope you have a good rest of your day. Goodbye.